Hey guys, I'm just going to go over some quick notes for you guys. So the Objective 12 file, the PDF, is your notes. And by the way, look who's here with us today. Say, hey guys. Hey, what's up? What's going on? This is Benjamin. All right, just wanted you guys to meet him. Okay, so let's get started. All right. As an introduction, this will help you with problem number 5. So 9 to the 1/2 power is the same as 3. Okay, think about that. 9 to the 1/2 power is the same as 3. So I'm going to rewrite something. I'm going to rewrite 9 as 3 squared. All right, 3 squared is 9, we know. So 9 is 3 squared. 3 squared to the 1/2 power is also 3. All right, those are equivalent expressions. If I'm going to rewrite this one last time to say, well, 3 squared is 3 times 3. Right, so if we say 3 times 3 to the 1/2, we really just mean let's use half of the factors. Right, so 3 times 3 to the 1/2 is just one of the 3's. All right, one thing I want you to notice is that using 1/2 as a power is really the same thing as the square root. Okay, and at some point you're going to have to think, and this is somewhere in your investigation. I want you to try to figure out what does the 1/3 power actually mean. All right, and it's very similar. Okay, so let's move on to problem number 4. Problem number 4. Now let's use numerical examples. Anytime you have a numerical example, you can just use Desmos and it'll give you the appropriate answer. So this is 2 to the 1/2 raised to the 2nd power. And it says the result is 2. All right. Another way to think about this is, well, we can say that 2 to the 1/2 squared is really having an exponent raised to another exponent. So this 1/2 squared, you're going to multiply those two exponents. All right, so 1/2 times 2 is 1. Therefore, you're just doing 2 to the 1st power, which is 2. Let's go back up and look at our first example and see how that is also true. All right, so we had 9 to the 1/2 power. When we change that 9 to 3 squared, you can see that I had 2 to the 1/2. 2 times 1/2 is also 1. So this is really just 3 to the 1st power, which is 3. All right, that's the power property, and you're going to run into that today in your investigation as well. All right. Let's see. So I've got a little information right there that if you have an exponent raised to another exponent, you need to multiply the exponents. That was Math 1 lesson. All right. And now to help you with problem 6 and 7. All right. You got an expression that says 64 to the 2/3. I can type that into Desmos, and Desmos tells me the value of that is 16. All right. So the value of that is 16. Oh, he doesn't like that. Okay. Oh, hold his head. Hold his head. Okay. So 64 to the 2/3. If you follow your notes in the little box, yeah, you can go. We can change this expression to 64 squared. There you go. To the 1/3 power. So 64 squared is 4,096. In other words, 4,096 to the 1/3 power is 16. So what I'm telling you right here is that voila, you can change the 1/3 power to the cube root. All right, to find cube root, just look under functions here in Desmos. So the cube root of 4,096 is 16. In other words, take a look at how 64 to the 2/3 is the same thing as saying the cube root of 4,096. All right, so that's how that works. Okay, this time what I did with my 2/3 is I factored it. I factored it into 2 times 1/3. All right, and that helped me think of it. So again, when you have an exponent that's a fraction, this is called a rational exponent. Let's recap it one more time. So 64 to the 2/3 is the same as 64 squared to the 1/3 because 2 times 1/3 is 2/3. All right, next I figure out what 64 squared is. Well, that's 4,096, and the 1/3 power is the same as the cube root. I asked you guys that question about 2 minutes ago. All right. Then here's an example with a variable, b to the 4/5. We got about 30 seconds. B to the 4/5 is the same as b to the 4th to the 1/5 power, which is the same as the 5th root of b to the 4. And to show you that this is true, I added a slider that lets you see that this is true for any value of b. All right, so that should help you out with your investigation. If you have specific questions, enter them into the comment section. I wish you guys all the best and happy studies. All right, take care.